Hi, Neil.
Hi, can you hear me okay?
Loud and clear.
Fantastic. I know not whether Naeem will join. Hopefully will do. Just depends on um, what
Not to
he's
worry.
doing. I know he's been in meetings, so we're aware of that. So that link worked okay. I guess the other one was maybe a meeting we had previously.
Well,
Um,
it's the same dates, but I'm not sure if it's the same meeting or whether
ah,
I've just got multiple invites to the same thing.
oh, yeah, that probably is. But maybe you joined or registered using the web page or something like this potentially. Um, but it's not important as long as we've this
Brilliant.
the only issue would be is if we're having a meeting and no one knows about it. That would be um, hopefully that's not the case.
Yes.
But yeah, no, I think is everything okay on your end there?
Yeah, I'm using two screens so that I can try and see what's going on and the presentation material at the same time. And every time I click anything, it defaults to mirroring so that I end up losing you. And
Okay, okay. Well, play with what we've got another sort of 10 minutes or so anyway. So no problem. Have a little play. So it's mirrors. Okay, so you basically got the same on two screens. Is that what you're saying? If it's mirroring
yeah,
it. Okay.
yeah.
Not quite sure how to change. That's a setup normally on the screens, isn't it? With the second one.
Yes.
Uh,
Yeah, but I think I'm okay as I am just now because I'm familiar with the slides as well, and it's only a dozen of them. It's not
yeah,
like
sure.
having a 300 slide pack. And can you remember what comes next?
Yeah, well, that would be a bit of a bit unfortunate, wouldn't it? Let's hope that we're okay. So, yeah.
Yeah,
So I think just to clarify, so I'll just do a very fast introduction. We're not
sure.
we know there's not been. I sent another sort of update on LinkedIn earlier on. Not much has come back, to be honest. So I'm not expecting many to be there, but I guess we just try and treat them with the same respect as we would do normally, and treat it as uh,
Absolutely.
yeah. Well, I mean, for us, and yourself, of course, and I keep going to the marketing collateral, but that's a really useful thing because we can just have the link itself to the video and send that out to interested parties and things like this. It's a good thing. So, and obviously gives you an opportunity to run through it also. Regarding the question, so I will what I normally do quite often with these webinars is I'll go through sort of optimization and stuff like that. That's not my intention. I will be literally 1 or 2 minutes, so you're aware, and it will be like you. I've got another screen which I'm looking at, which is probably pretty obvious. But so I'll just introduce myself quickly as sort of be business development with
Of course.
OWE, Oxford Well Engineering. Um, so but instead of saying digitization, I've got we help operators and service companies, regulators to improve P&A practices through practical solutions, workshops, and trainings. And today we're joined by Tom Leeson. I think somebody seems to have joined the event slightly early. Hello there, Handrawan. How are you, sir? Okay, I don't. He's probably
It's not
muted,
on
anyways.
yet.
Just
Yeah.
to let you know, Hendran, we will start at probably 2 or 3 minutes past 3 o'clock, so another 5 minutes or so. Um, and I will just wait for anybody else to arrive before giving some instructions for the webinar going forward. But if you just hold on for a little while, that would be great. Thank you very much. Good afternoon, Naeem.
Hello, how are you doing?
Very well, thank you. There's a gentleman has already joined, I believe, Hendrawan, on the left there. So, um, although we're starting, I've just discussed with Thomas, so we'll leave it until maybe 2 minutes past 3. We think everything is hopefully in position now. So Thomas, you've got the slides available to you.
Yeah.
Fantastic, and so you can just share those when you feel it's appropriate.
Yes. Yes.
Okay, very good. Okay, so what I'll do now, and if you're okay, I will just and like I would suggest, but maybe you could probably mute and camera off for yourself maybe as well, just so we're not sitting here for 2 or 3 minutes looking aimlessly at the camera, if you like.
Yes. Yeah.
And if we all come back on again at 3 o'clock, would that be okay? Fantastic. So I'll speak to you very shortly.
Waldo, kौन है?
Are you there, Thomas? Or Tom, rather?
Hello, yes, Neil, I'm here.
Hello again. Okay, hello everybody. Thank you for coming this afternoon. As you can see, there's not very many people here at all. So sometimes these things work out. Maybe Mr. Trump has something to do with that. I do not know. But I think rather than waiting, if we just continue from now. So we do appreciate both yourself, Rick, and Hendrawan for being here. What we would intend to do is to just carry on as normal. So I will give you a very brief introduction and then hand over to Tom, who of course is our speaker today. And then he can take you through Well, hopefully it will be a very interesting talk, actually. Initially, my name is Neil Jones. So my background is geology and geophysics, and I work in business development with Oxford Well Engineering, OWE. OWE helps operators, service companies and regulators improve, in this instance, P&A practices through practical solutions, workshops and training also. Today, we're going to be joined by Tom Leeson, Dr. Tom Leeson, in fact, who's a resident P&A expert who has extensive field and technical experience. So he's worked globally as a P&A specialist with over 30 years of experience, and also 1,200 plus P&A designs across 17 countries. Covering platform, subsea, and also, of course, rigless operations. So if I now hand over to Tom, we will get straight into it, I think, as there's such a few people here. I think just before I do that, Tom, maybe as there are limited number of attendees for now, and of course we will be recording this, so it will be useful. We can provide that sort of information later on at the end. Normally, I would say at the end we would go through some questions and answers. As there are so few people here, then providing Tom is okay with it, if you do have any questions, please feel free to just put your hand up, and then we'll leave it to Tom to answer those. But if anything is left to the end in terms of questions, we will of course get back to you afterwards with a more detailed answer, if you like. So if I just hand over to Tom now, you okay with that? You can share your screen?
Yes, thank you very much, Neil. Yes, that arrangement for the questions is fine. Let's see if I can make this work. There. Are you?
Perfect. I can see that.
Excellent. Thank you. Right, I should be in good shape. Well, good afternoon, everyone, or good morning or good evening, depending where you are in the world. Thank you for joining us today for the latest in this series of topical webinars that Oxford Well Engineering run, this time focused on abandonment. As Neil was saying, I've worked in this sector for a long time, more than 20 years in well abandonment, and I've had a variety of roles. So I've worked in engineering consultancy, I've worked in project execution and operations, service delivery as well, and technology development. So I'm very grateful to OWE for inviting me to lead this session today and to share some of those experiences. Achieving cost-effective and compliant abandonment while minimizing the costs. That's at the heart of what we're trying to achieve and at the heart of the challenge that we have. So over those 20 years, I've been on some successful projects. I've been on some that are perhaps not so successful. I've seen some mistakes and I've made some mistakes, and I've seen some really great approaches to problem solving and cost reduction. So in a way, this session today is almost a magpie exercise of collecting those experiences, and even with that experience, I always feel uncomfortable with the description of as an expert because nobody knows everything, and I certainly don't know everything. But hopefully there will be some nuggets in here today that you will find interesting as well. So what we're going to do is we're going to focus on some key areas. I really want to emphasize the good engineering practices that when we follow them, we end up with good results. And sometimes there's been a tendency to treat abandonment perhaps with less, I don't know, less respect perhaps. And those practices aren't always followed. In addition, I want to highlight some really successful strategies and tactics that people have used on the projects that I've been involved with, um, and then lastly to identify some critical steps in the engineering and execution phase that I've seen be really important, really critical in delivering success. And the way we're going to do that today is we're going to walk through a typical project workflow to allow ourselves to see how this might progress and how this delivers results. So first of all, we need a sort of illustrative asset to work with to help us illustrate the challenges and the approaches. Uh, so today we're going to be thinking that we have a single integrated platform with a number of platform wells, a mixture of producers and injectors. There's a handful of subsea tiebacks as well, but they're all from the same drill center. And on the platform, we've got a derrick system in situ, although it is cold stacked. That might ring an alarm bell for people if they've ever been onto platforms and tried to resurrect derrick systems again. In addition, we've already got some known well conditions. We know that we've got annulus pressure on some of the wells. We know we've got tubular corrosion, particularly in the water injectors, and we've got some seal integrity problems in the wellheads as well. Now, these are all being managed. These are all manageable challenges, but they're also very typical. And of course, if this is typical for platform wells, one of the things we should be thinking about, well, even if we don't know for certain what's in the subsea wells, do we have any reason to believe that it would be different than what we're experiencing? Of course, it might be. Your metallurgy might be different. The reservoir you're dealing with might be different. But oftentimes the problems that you see with platform wells, we will see with subsea wells as well. We just don't know it yet because we haven't got access to the well. When we start a project, what have we got? Well, actually, what we should already have is a liability estimate, or what's sometimes referred to as an asset retirement obligation estimate, an ARO. This is a legal requirement because we have a known cost in the future. We know we are going to have costs associated with the decommissioning and abandonment of the field, and therefore the company that's responsible for that must carry that liability on its balance sheet. So we need an estimate of what that liability might be. And so typically what's done is a simple deterministic estimate. It's I don't think I've ever seen all the wells reviewed at this point. It's usually a selection of the wells. So for our 16 wells plus the subsea wells, in this particular instance, there were 4 wells selected, and for a superficial review to come up with a conceptual design of abandonment that we can then put a most likely duration on, and we can have some most likely or reasonable unit costs associated with those activities. And it's so we're going to create our liability estimate, or that liability estimate's already been created using this approach. And here's for illustrative purposes, here's an example. We quite often add allowances there. There'll be an allowance for engineering. We might have additional allowances for weather and NPT if we haven't already included them in our durations. And what we should do is we should benchmark these. We should make a comparison between these and data from the sector. If we've got our own data, of course, that's very convenient. but it would be good to test it against other operators and other fields. The NSTA, for example, the regulator in the UK, shares a lot of data that allows people to be able to benchmark themselves against industry performance. If our numbers are different from the benchmark, what does that mean? Well, it doesn't mean we're wrong. There might be very good reasons why our costs might be lower or higher than the benchmarks. But it should raise some questions for us that we should not ignore. So we ought to be able to have a reason why our numbers are different. Why are ours lower than the benchmarks? Or why have we ended up anticipating to be much more expensive than the benchmark? This type of estimate doesn't have a very high accuracy. I would say typically we're talking in the range of -40 to +100%. That's quite wide. But if we go and look at good practices and recommended practices, and indeed look at empirical experience in our sector, in the oil field, then this is not an unreasonable accuracy range given the limited amount of engineering we've done. So we would refer to this as a lower class 4 estimate, and in the good estimation practices that I'm highlighting here, I'm making reference to a non-profit organization, the ACE. So that is the Association for the Advancement of Cost Engineering. It's a not-for-profit based in North America. It's pan-industry. It's not oil field specific, and they have a remit to develop and promote cost estimation excellence and good practice. It's a really useful organization to be a member of. Lots of information, lots of good practices, and lots of discussion groups around some of the challenges in estimation if you're working in that area. So when we start our project, we have a liability estimate. But is that our project budget? Okay, so what we need to report for our liability is a reasonable estimate of our liability. So we could think of that as being a P50. Yeah, it's the one that's you can say, well, that's reasonable to assume. If I have to pick a number, I'll pick the one in the middle. Is that what we want for a project budget? Do we want to be over budget 50% of the time? I would suggest not. So the objective of the estimate changes from this to a project budget, and therefore the basis of estimate changes, and therefore the estimate changes as well. So we would still use ACE's recommended practices, and we'd use their template for basis of estimate. But to do a project budget, we really ought to look at each well. Clearly, it's the start of the project. We won't solve all the problems. We won't even identify all of the problems, probably. But we should at least have a look at each well. And as we do it, we should prepare a really comprehensive technical risk register. Every time we have an unknown or an uncertainty, we have an additional technical risk. And we should recognize that, and we should understand what is it we're going to do if that risk turns out to happen. If that unknown or uncertainty and the assumptions we've made around those are wrong, what are we going to do? And typical things we're talking about, what about when we start circulating and we get losses? What about if we go looking for the cement behind the casing and it's not where we thought it was? Or maybe it doesn't even have a seal. So these type of things that we don't necessarily know until we get into the well, we really need to recognize this is absolutely fundamental to getting lowest cost. So many times I've seen projects or well operations go over budget, and afterwards the comment is, well, such and such happened in the well. Well, could you not have predicted that that was a possibility? You didn't know it was going to happen for definite, but if it was a possibility, were we really ready for that possibility? Did we know what we were going to do next? Did we have contingency procedures in place, the contingency operations program? Did we know what services we were going to need, even if we hadn't mobilized them? Did we know what we were going to need to call off? So really, really important. This time, this class 4 estimate is going to be a probabilistic one as well. What we're going to do is we're going to recognize that when we choose a most likely duration, we've also got a lowest duration, which you might think of as something like being at the technical limit. And there's also a possibility for overrun. And usually that is not a symmetrical arrangement. There's usually much more chance that you're going to take longer or it's going to cost more than it's going to be less. And that skewing of the distribution of that variable means that if we run a Monte Carlo analysis on our key variables in order to calculate a probabilistic estimate, then what we end up with is a curve that looks a bit like this. This is one particular example. And you can see that there's a skew there with a long tail towards the left-hand side. So we work up this probabilistic model using conventional abandonment methods. We want a base case which is unquestionably compliant, unquestionably deliverable. But what we want as a project budget isn't the P50. It's probably going to be something like the P70 or P80, so that, yes, you can't have the P99 because that's a ludicrously high number, but we want to reduce the risk of us running over budget. So I would suggest that it's good practice that we take something in the P70 to P80 range. Now, what we also need to recognize is that in that variability of delivery, of the most likely outcome of cost here, we've taken into account changes in duration and changes in unit costs for our base case. If we have additional activities that we need to do, those need to be budgeted in addition. And so in this particular example, I've suggested that the budgeted contingencies at this point in the project will be something like 45 million. And that's not unusual. Something like 20 to 30% of the base case, you could argue maybe even more. While we're doing this, we start to recognize what the alternative cases are that we might be able to use for abandonment, and what novel methods we might be using, but we wouldn't include them yet in the project budget. If we look at the well delivery process, where we're going to go through our gated process, typically assess, select, define, and then execute. This is Oxford Well Engineering's summary or summary of their process. What I would say, there's two key factors, particularly for well abandonment. One is we should go talk to our regulators. We need to understand what our regulators' expectations are in terms of what the barriers look like and how they'd be tested, how they would be verified, how open are they to us using new technologies, and what extra assurance might they want if we were to do something like that. We need to be very comfortable that we've got a full understanding of their expectations before we start getting into designing the concepts in any sort of detail. So this is an action to take up for very, very early in the project. In addition, I'd say in my experience, having an independent compliance review when the detailed designs are done is also an absolute key step in the process. There are some areas in the world where this is done, but with the use of a well examiner, so this is already integrated into the process. But that's not true elsewhere in the world, and I would strongly recommend that people consider this. This is the way to make sure you are compliant. But we have to ask, compliant with what? Because in many instances, the regulators do not define prescriptively what is expected, which is good because that means we have flexibility, we have opportunity to take different approaches, to deal with different challenges differently. That's what we want to do as engineers. But then it says, well, how do I know I was compliant? So we have to have a standard. We have to have something to work against. And so our initial actions are that regulatory engagement, confirm what I refer to as an abandonment philosophy. We could call this a technical standard, but I don't think the name of the document is really important. What's important is what's inside it. And the key things that we need to do here is we need to define what barrier options are allowable. What do we consider to be good practice, and are there limits on the applicability of certain options? Can we only use them in certain circumstances? We also need to confirm how we are going to verify our barriers. And then, so are we purely going to pressure test? Let's say, for example, we put cement in the well. Are we just going to pressure test the cement? Or are we going to collect more information? And of course, that becomes particularly important if you're talking about new and novel technologies and methods, because you want more confidence in them, and therefore you need more verification. What I would say as well is that at this point, you've also got the opportunity, and I've seen this done very well, to incorporate what I call a risk-based design approach. So if we compare two wells with very different risk profiles, there's an argument to say that the more challenging well, we work to a more rigorous standard. Now, there's some question marks about that, because you would say, well, why don't we work to that standard all the time? If this has to be as low as reasonably practicable in terms of the risk of loss of containment. But from an engineer's perspective, if you had a subhydrostatic sweet gas well with no corrosion, would you really expect the solution to be the same as if you had an oil well with corrosion issues and the ability for the reservoir to recharge, and the possibility for pressure differentials to increase over time? Would they be the same? The key thing here is that you have an abandonment philosophy or a technical standard that you can then be measured against. And that is how you ensure you have compliance. Finally, one of the first things to do is to get a geological assessment done. If this is not already available, we need to know which formations need isolation and which formations are potential cap rocks for us, which ones are effectively impermeable, and we can set our barriers opposite to restore the cap rock in our abandonment approach. And finally, what we should be doing is making sure that we've got a pore pressure plot so that we understand what pressures may be seen in the wellbore. And that then allows us to determine minimum barrier depths. So our barriers are deep enough that the formations opposite the barrier are strong enough, they have enough integrity to manage the pressure differential that they may see in the future. So very important steps to get that in place first before we start looking in the well and start worrying about, well, you know, do we have cement here? Do we need this there? This is the basics. This is where we start. Taking a typical project progression. We've talked about a lot of these at the start already, but in here, I would say this is also the time when you go data and gathering. Whether that's going to the field and collecting data from the wells, certainly there's some key information that if it's not available, we want to go and get, if we can at all get access to the wells. And of course, again, this is where subsea wells become more challenging because that's so much more expensive. If you can manage without it, you would probably try, and I think that's reasonable. But platform wells, let's go and find out what's in the annulus. Let's go and find out what pressures we've got and so on. But it also means going back in the archive boxes, going and finding the original end of well reports, going for the daily drilling reports. There's a lot of information in these documents if they were written well and they've been kept. Sometimes it's not an option. The data's not there. It's gone. The information has disappeared. Particularly when assets have been handed over from one operator to another several times, data leaks out and disappears, especially when it was only on hard copy. So, but if you can, go and find it out. Well worth digging through all those archive boxes and seeing what you can find. As we move on through the engineering phase of the project, we want to really focus on the alternatives that are available to us and working out whether they are feasible or not. We need our contractors at this point. At least by this point, we need to have significant contractor engagement. You want to understand where the sweet spots are for their technologies. Which ones do you feel comfortable and confident in which area? And if there are new technologies that actually you go, well, they could be a game changer for us. They could be really useful, but you're not yet confident enough to put them in the well. Well, of course, this is the time to go and do the field trials. That might not be in your own wells. You may be able to team up with other operators, and I've seen that done quite successfully in Norway, particularly, but elsewhere in the world as well, where you can get the opportunity, maybe on a land well where services and so on are cheaper, that you can field trial these technologies, and you can spend more time verifying the success. I'll give you an example. If we're trying to get a barrier in an annulus behind casing, and we use a technique which leaves material in the wellbore as well as in the annulus. That could be perf wash and cement. It could be using new polymer materials or bismuth alloys. There's lots of options now to remediate annulus pressure, but if we pressure test the the material in the wellbore, does that really tell us very much about what's in the annulus? And if we're not lucky enough to have a casing shoe nearby that we can that we can straddle, we're going to struggle to pressure test the material in the annulus. So how do we know that that annulus material is good? Well, what I've seen done is that the material's drilled out through the main bore, and they go in and log. If it was a cement circulation, for example, log the cement and understand and confirm the quality of the cement bond behind the casing. And if we get good results with a certain set of operating parameters, pump rates, fluid volumes, viscosities, hole angles, and so on, and we can repeat those parameters in our wells when we're abandoning them, well, then we can expect to get the same results. And we don't have to drill out and log every plug. So really, really useful to do this at this stage. I've also got in here, because I put into the asset that we had a derrick. Well, we need to assess whether we actually want to reinstate that derrick. And actually, I think the industry experience, certainly my experience, is that the reinstatement can cost significantly more than you initially think, which obviously makes this less attractive. But in addition, what kind of uptimes can you expect from old equipment? How easy is it going to be to get spares? How easy is it going to be to repair and to find competent technicians on old equipment? So be very careful if you want to use an existing derrick. When we get into define, of course, we're going to build our detailed program designs. I'm going to reiterate this one. We want a detailed program written, reviewed, and signed off for every major contingency. This is how to get lowest cost. Be ready. Do our independent design review at this point that we mentioned before, and do our contractor selection. Then when we come to do the work, ideally we put it in campaigns of work. And so for this, we would expect to do all the platform wells together and all the subsea wells together, but in two separate campaigns. Give yourself the chance to separate those and focus on the specific challenges in one and then in the other. But what I would say is very often I've seen what I call batched operations being utilized, so that all the reservoir abandonments are done first. And then we go around the wells again and we do the intermediate abandonments. And then we go around again and we do the environmental plugs if there are some. And then we do the wellhead removal, the conductor removal, whichever is appropriate. Because at each stage, we can have a different spread. And we're only paying for the services that we need. If we can do the reservoir abandonment, for example, without pulling tubulars, then we can probably do it without a rig. But if we need a rig or a hoist to pull casings in order to do the intermediate abandonment, well, then we bring that capability on site when we need it and then demobilize it as soon as we've finished. So we do all the work with that spread across all the wells, and then we demobilize that and we mobilize the next spread. That can have a huge impact on costs, and it really focuses the engineers and the crews on being efficient and learning as we doing the same operation over and over again. We definitely get better. Finally, what I'd say for those not so familiar with this, an abandon the well on paper exercise at least before each batch of operations, and making sure that that involves the key personnel in the service companies, the personnel who understand what they've got to do to operate the tool downhole. You actually want the operations personnel in the room, but you want their technical advisors as well. You want the people who understand the limitations of the tool, and the circumstances it needs to be worked in. So really, really useful exercise where everybody starts to hear, oh, you're going to do that in the well for your tool. Ah, right. Okay. That has a consequence for my service. And those interfaces need to get flushed out. We need to be really, really efficient and ready, know what's coming next, and know what the implications are for each person in the team needs to know what the implications are for them and their service. So there's lots of opportunities here to get costs down. We have to focus on them. A lot of the effort is put into understanding what other people have done successfully. So reviewing peer practices is a really useful thing to do. Definitely recommend that. Get with your supply chain, find out what they've got, what's new, what's emerging, where has it worked, where has it failed, why did it fail, what did they learn, and of course, potentially alternative commercial arrangements to the normal time and materials charging. We've got a very defined end goal here in well abandonment, and we should have a very defined risk profile because we should have a really comprehensive risk register. When you have those two things, lump sum type pricing, pricing for performance starts becoming more interesting, and you're more able to utilize that kind of approach. The more risk that's in there, the more unknowns and so on that are in there, the harder it is for the service sector to give you any kind of lump sum price that doesn't have a lot of extra contingency in it. Contingency that you might not necessarily need to pay for because those things may not happen, but the service company needs to protect themselves. So we've got alternative methods. We've got our technology trials. We've got our risk-based design I talked about before. And we've got our campaigns with different spreads. Lots and lots of ways. We need to utilize all of these. We need to attack this from every angle. But if we do, typically we can get between 25 and 40% cost reduction compared with our base case. So if we take our typical project that we were working with today, that was $255 million plus a contingency. So we are talking potentially in the order of 80 to $100 million being taken out of that cost. That's a big deal, but it's achievable and it's regularly done. So the project budget had a base case, but we're not going to deliver it for that. We're going to deliver it for a lot less than that because we're going to use all these opportunities. Risk management, yes, that technical risk register, we need all our assumptions in there because they all carry risk. Are there things that we can go out and we can find out, we can get the data, we can collect it, and that's no longer an uncertainty, it's confirmed, or it's not an unknown anymore, it's a confirmed value. But for everything that is a residual risk, we either need to develop some alternatives and do something different, or we need to have the contingencies fully worked up. The maxim here has to be no surprises. There should be no surprises in these wells. There are almost no unknown unknowns. Most of them are known unknowns. We know that we don't know them. So we should do something about them. Moving on to the design phase, and just some key areas in the design considerations. When we're thinking about uncertainties and contingencies, particularly a focus on the cementing records and the tubular integrity. If we're going to pull tubulars, could they part? Could they get stuck? If we are going to circulate through tubulars, do we have integrity? Do we have leaks? If we have leaks, how bad are they? Would they affect the effective circulation or not? These are the things that we really want to know and understand what the consequences might be, and what's our contingency going to be if we get out there and we find that our casing parts, for example. There are some preliminary work scopes that we can get done and will give us information. We definitely want to go out and do a full wellhead maintenance routine. We want our wellheads to be fully ready when we're out there working on them and intervening on the well. But we also, when we're out there, we want to sample all the annuli. We want to understand if we've got gas or liquids in the annulus, if we've got pressure. We actually, if we don't already have it, we want to understand the pressure profile and the recovery. Is this pressure coming from a formation? Is it coming from a casing leak? If it's from a formation, where is it coming from? If we take samples, we can often get a signature composition, which will allow us to understand whether this is coming from our production formations or whether it's coming from somewhere in the overburden. And that's really key to understanding what the challenges will be in the well. We can also do things like fiber optic investigation. This isn't a service that I've used, but I've seen some presentations on this, and I know one or two people who've used this, where you run fiber optic in the well and effectively encourage the annuli to flow, and you can hear through the fiber optic the flow behind the casing, and you can effectively work out where your flow is coming from, and indeed where it's going. Do you have cross flow between multiple zones, or do you have a formation in the overburden that is delivering you your annulus pressure? And then finally, the other preliminary work scope is to go out to the well with your wireline and maybe a pumping spread and go and do what is sometimes referred to as a plug and lubricate program. So you go in, fill the annuli, kill the well, put wireline plugs in the well, get the well to the point where whatever is coming next, the well's ready for it. So if you're coming with coiled tubing, or you're coming with a rig, or you're coming with an intervention vessel for a subsea well, no, that doesn't make sense, does it, for a subsea well? That would be the wireline plug and lubricate program. Sorry. But yeah, for platform wells, you want the well to be as ready as possible. So go out there with what is effectively a very cheap spread and get as much work as done with wireline and maybe a pumping spread before you go on to actually installing the barriers. Lots of different barrier types. A couple of things I'd like to highlight here. Perforating and circulating cement. It's quite common practice, but I just beware that you're confident that you are getting some full cement circumferential coverage in that annulus, and you're not getting the cement just migrating to the high side and leaving you with a gap there at the low side, a channel. Some activities now can be run on coiled tubing, including PWC or perf wash and cement, which is a cementing technique for the annulus. There's several different tools and tooling providers out there now providing that type of service. There are other technologies I haven't put on the list here because I haven't used them, like bismuth alloys and polymer solutions. But one that I have seen used was very innovative when it came, I think, when it came in, which must be now 8 or 10 years ago, is using squeezing shales as an intermediate barrier. So if you've got a shale formation, which is impermeable and could be your cap rock, and it has squeezed in against the outside of your outer casing, you may already have a seal in your annulus, and Mother Nature will do a better job than we will. So uh, there are occasions when we don't need to put cement in the annuli to create a barrier, but what we will need to do is validate that barrier is working. So we will have to pressure test it. But it's a really interesting alternative if you're lucky enough to have that kind of geology. Lastly, we talked about risk-based design before. The two areas I think were interesting. One is in barrier length, because why do we have 100 feet of cement, or why do we have 50 meters of cement, or even 30 meters of cement in different guidelines and so on for different barrier lengths. The barrier length can be a function of the method that the barrier has been put in with, because some methods are more prone to contamination and so on, and therefore you want a longer length so that you've got an area that you're confident with. Whereas other installation methods might be more efficient and don't need so much length. There's also verification methods. If you've got lots of information that gives you confidence about where the cement has gone or where the barrier material has gone, and that it's gone off, then maybe there are circumstances where you can say there's a low risk here, and I can minimize my verification methods and maybe not even pressure test the plug, depending on the circumstances in the well and what you've already done in the well. So heading towards the end now, heading towards the execution bit. Well, of course, if we've done lots of things well by the time we get to this point, we should be in great shape. What we need to do now is manage the operations well, safely, efficiently, logistically, and so on. You can make lots of mistakes potentially in those areas, but I would hope that that's actually the easy bit. That's the bit that we generally do very well. In this particular instance, with this typical project, the way I've seen platform wells approached. So we go out with a wireline spread, kill the well, put our wireline plugs in, then come with a coiled tubing spread to abandon the reservoir, then demobilize the coiled tubing, mobilize HWO unit, and abandon the intermediate zones, remembering that we're doing this on all the wells. So we don't start at the bottom of the well and end at the top and then move to the next well. We hop from well to well to well and come back, and then we do the next stage, the next phase on all the wells and so on. And then in this instance, in the platform wells, we even demobilized the HWO unit and we brought out a pulling hoist to recover the tubular strings, the conductor strings. There's no well control required now at this point. The well's been fully isolated. We don't need something as sophisticated as an HWO unit. Subsea wells, I've seen it makes sense to use an intervention vessel to go and do an initial plug and lubricate, then bring the rig in to abandon the reservoir and intermediate zones. But typically with subsea wells, you'll have an environmental barrier at the top of the casings just below the mud line, and well, the wellhead will be removed. We don't need the rig to do that. There are rigless options for putting the environmental barrier in place that can be deployed from construction vessels, much cheaper spread rate, much quicker operation, and the wellheads can be cut and recovered very quickly. There are many service companies doing that kind of work, so lots of opportunity to do things differently, and release the rig. Try and get your spread rate down at every opportunity. So what would our likely outcomes be for a project like this? Well, if we've taken this approach, we would certainly expect to have regulatory acceptance, and we expect to have compliance with our standard. It's not unusual to be able to deliver significantly under the initial project budget if the initial project budget was done the way I propose. I'm suggesting here that 30% is quite a reasonable number. So we were talking in the region of $170 million, plus some of the contingencies were needed because some of those risks did materialize, and we had to spend that extra money. So we came in at 195 million. Well, given that our original estimate was 150 million minus 40 plus 100%, we're definitely in that range. We started out at 255, and we've delivered significantly under budget. What I would say is a lot of that comes from being able to deliver operations efficiently, and typically see something like a 40% reduction in the time per well over the first 4 or 5 wells. That is doable. After that, it becomes a lot more difficult to get the improvements. But initially, in that initial period, focusing on efficiencies, getting the crews involved in what makes sense, what needs to be ready next, which order should we do things in, really, really useful and real good cost-saving area. The average durations do tend to be more than what we anticipated. It's just the way it is. It just shows how much emphasis we have to put on good estimation, realistic estimation, and operational efficiencies to be able to do them close to the technical limit consistently. Those budget contingents were only used when required. I would say it's good practice that you allocate contingency money against specific challenges. If those challenges don't appear, that money's not available. That's the way to really control spend. So to summarize, last slide. We need to understand our geology. We need to understand our regulator. Engage with them, talk to them, find out what their expectations are, get into a dialogue with them. Appreciate the difference between an ARO estimate and a project budget. We're going to use them for different things, so the basis of estimate is different. Use probabilistic estimation if you can. I find it really useful to illustrate the uncertainty associated with the project at this stage of the project that we're sitting at, and allows management to see really clearly where the what they may be dealing with. We want to use good practices as well in all instances. Risk register with unknowns and uncertainties. This is a key thing for well abandonment. This is something that I've seen lots of operators do really well, but going back 10 years, it was a challenge to get some people to recognize that this was important. I think people do now. That risk-based approach to barrier specifications and verification, so that we maybe make it more onerous when the risk profile is high, because we want to be compliant and we want we don't want loss of containment. But it means that we can take a slightly less stringent approach when the risk profile is different. Independent review to confirm our compliance, having a standard to work against in order to have something to measure us with, and a flexible approach to how we program the work. We don't have to start at the bottom of the well and finish at the top. We can group the wells together into one work program and then schedule them for the most efficient way of doing things. So I think that was a little longer than I anticipated, but we do have some time for questions or observations. Neil, would you like to take over?
Yes, certainly. Thank you very much, Tom. That was excellent and very much appreciated as well. So I do appreciate everybody having taken the time to join us. So if there are any questions or clarifications, we're very happy to address them now or offline. Either way, I think we will also follow up by email with you, and possibly with the recording also. I'll clarify with that with Tom afterwards. Of course, we need to make sure that that's okay with him. But if that being said, any other information you may require regarding other courses we may or webinars we have coming up for P&A or well integrity or similar, we'll provide the information for that also. Really, again, just thank you very much for your time and spending it with us. So, is there a question there from you, Rick? Can you hear okay still, Thomas?
Yes, absolutely.
Fantastic. Rick's just typing something in the question there.
Oh, thank you. Thanks, Rick.
Go. Very
Appreciate
good.
that. I see, actually, there's a name here I recognize. Susie, Happy New Year.
Aha.
We'll find out whether she's still at her desk.
Yeah, I think so. I think the webinar is enabled for typing only, I think, as opposed to the discussion. But oh, there you go. It's coming through.
Thank you, Susie. Appreciated.
Yeah, so I think Tom, really just to reiterate how good that was. I think it was excellent, very condensed, to the point, and we can see, although not a great deal of people here, the people that have attended here, they're specialists in their area, which is very important. So unless there's anything else you would like to, or any other questions, just type them in now. Otherwise, we will, as I said, follow up with you afterwards. Is there anything else you would like to say, Tom, before we close the meeting?
No, it's hopefully it was clear. You know, there's no silver bullet here. There's just the hard yards of doing your engineering work diligently, really focusing on the details and making sure that they're dealt with. The unknowns and uncertainties are the things that trip people up. Oh, that'll be okay. No, I can assume that. Yes, you can at this point, but you don't want unmanaged assumptions going out into the field.
Yeah, I would agree with that. That's great. So I think if we end it there, that's good. And also, as there's not many people here, I can say hi and thank you very much for attending to Bevan as well. I know you guys have had a long day, I'm sure. So if I leave it there, again, thank you very much indeed. And we look forward, hopefully, to speaking with you again in the near future. As I said, we will send you some further information. And if anybody wishes to know more about any tailored courses or anything like this, and please don't hesitate to contact us either by email or LinkedIn or whatever is easiest for yourselves. And also, just regarding Susie, I know we don't know each other personally. I know you, as it is obvious, you do know Tom. So hopefully you can appreciate how valuable this is. It is very interesting for us going forward to have any feedback from the NSGA or yourselves how we can improve this process too. So again, thank you very much, and we will end it there. So have a good day, everybody, and thank you.
Good night, everyone. Thank you.